Hello, everyone. Welcome to another Workflow Wednesday. So as you can see, I already have my setup created for this part. I'm actually going to go in and I'm going to create a very generic 3D toolpath. I'm going to go with scallop, and we're going to go ahead and do just a selected boundary, contact point boundary with the tool staying on center. And then lastly, I'm just going to give this a 1/4" ball end mill. So here we go. And the last thing I'm going to do is just give it a very generic, simple step over to calculate off of. So if you didn't know, upon calculation, down here at the bottom in your toolpath visibility, we could actually turn on the points. The value of being able to see the points to start with is one, collectively, every time you see a point, we're making a change in the axis. We're moving in, we're moving up, we're moving out. Basically, it's the tool changing from its previous segment. So if I zoom in here a little bit and you think about it, we come out of this corner to this point, probably a G2 or G3. Then we're going to G1 up to here and then G1 again. So because the tolerance is so tight right now on this back face, what in theory is just a straight line is actually having some variance to it. So now for some of you, you probably also suffer from things like your machine runs slower with a high tolerance or your data starving your machine. So what I like to do is first and foremost, look at my file size over here on the left. So currently we're sitting at 2 megabytes worth of data. And that is going to be a pretty hefty file to send for a relatively simpler kind of profile. So the first thing I would tell you is let's go in and let's look at our tolerancing. So currently, my tolerancing is set to 4/10, which is overkill for this project, right? My customer is telling me my tolerance is ±3 on my drawing. So what I'm going to do is very first thing is I'm going to go in and I'm going to actually put this to half of that. So if I'm working with a 3 thou tolerance on my mold, in this case, I'm going to put 1.5 here in the tolerance menu. And what you're going to notice, this is going to actually dramatically reduce my file size by almost half. We did actually bump that up by 3 times. Fusion isn't going to give me the exact data until we get under 1 megabyte, but presumably it's a relatively much cleaner file. As you're seeing, the points and the amount of black on this actual sketch have dropped dramatically. Now, again, what we're allowing Fusion to do is to create less points to create this surface for machining. Now, creating less points does have some good effects. If we get too crazy with this now, what I'm going to do is we're going to go ahead and go back in there, and you'll see this much better. Let's say we take this way out. Let's go up to about 50. So what's going to happen with something like 50, we're going to get what I like to call the stop sign effect. And you can actually see it around the perimeter of this part. We have reduced the points so much that we are making very, very straight line motions. We've kind of ditched the idea of making arcs at all. And you see that very clear up here on the top of my part. This toolpath is dipping even into the part a little bit because we've said, hey, as long as you're within 50 of that surface, you're going to be more than okay. Well, now see, we overkilled this. So again, our file is absolutely tiny. However, our surface is going to look terrible. It's going to look like a pyramid. It's going to be very square. So there's a compromise here. So now if we actually go back, and again, I'm going to go ahead and switch this back out to the 1.5. Now, down below, you have what's called smoothing. And what I love about smoothing, and if you guys remember, it was 1 meg before we did this, smoothing is actually the ability to reduce the points, but not necessarily reduce the arcs, right? So if you're coming into a couple of curves, if we can eliminate one of those points and make that curve much cleaner, that's what we're setting with smoothing. We're also doing the same thing in linear straight lines. If a straight line has a point in the middle of it and it breaks it into 2 segments, we could actually use a dimension of tolerancing. Again, it looks a little weird because this is smoothing tolerance versus tolerance. So again, tolerance is how close we are to the model. Smoothing tolerance is basically how close are our points aligned to one and each other and whether or not we can eliminate one. So by putting on, again, I'm matching my smoothing to my actual passes tolerance and hitting OK. You're going to notice that our file size still came out the same and we really didn't see a big change. And the reason for that is because those tolerances are too closely identical. So if I was to go back into this file now, and I'm going to go ahead and go to my passes tab, let's bump this up now to 3 thou. So we've actually doubled our smoothing. And as you're seeing again, is we're getting no change. So I'm giving it more and more and more without the outcome of really seeing any points reduced based on the file size. Now, if I wanted to verify this a little deeper, what I would do is I would go in and I would post-process this. I'm going to throw it on a FANUC machine. We're going to get our G-code spit out. And then in this case, I'm just going to real quick reveal this in the File Explorer. And then we could take a look at the actual properties on this file. And you're going to notice that we're sitting at just under 1 megabyte of file data. So again, if I go back to everything that we're doing, and we adjust that one more time, let's double it up and see if we can get a change here in the window. So let's go up to 6. And again, now we're under 1 meg. So we are seeing that change. So we are slowly reducing points by increasing that smoothing tolerance to be able to go in and trigger a much cleaner profile without actually creating straight lines that should be arcs. So now there is a point of diminishing returns on this, right? So I always like to take it to the extreme. So if we actually go back into our passes tab and we bump this out to like 50, I am going to get a warning here. And what this warning is going to do is tell me that the smoothing tolerance is greater. Obviously, we know that we're way up and above. We're at the extreme. But what it really does show you is how much it's going to stop trying to do straight lines and start to do more arcs than anything. And that's what you're starting to see here. So at 50 and that 1.5, we have eliminated a lot of these outside points, right? We're still getting a little bit of points here and there. Again, some finer tuning adjustment of the tolerancing itself. So if I went back to the normal tolerance, we bump this up to 3 thou. Again, we're still getting that warning. That file size is going to keep getting lower. We're missing some segments here. Again, the idea is that by increasing the tolerance and increasing the smoothing, we're allowing the points around the surface to float around a little bit to get a much more smaller file size. Again, because of the smoothing, we've eliminated the idea that we're going to start to stop sign affect our profile. However, we are going to start to see some very bad returns, and you're seeing it right here. So smoothing in this case has caused a problem where it has actually removed our straight line segment here. It has gotten so large that it's actually jumping over what should have been a straight line segment. So again, we go back, and I'm just a big fan of either matching or doubling whatever my tolerance is. And this is a very quick way to reduce a ton off this file. As you can see, we've gotten the file size down by half. Again, if we're concerned by data starving, we're concerned about other things at the controller, we could do even more by increasing that tolerance. Now, again, a lot of people are going to ask me, well, we've increased the tolerance. Can the tolerance be bigger than the actual tolerance of the drawing? Yes, because the tolerancing we're pulling on these surfaces is how close we are getting to the surface, right? I am a big fan, and this is just me, is I come in on my Fusion 360, is I actually take my tolerancing most cases, I set it to 4 thou. And the reason why I set it for 4 thou is because when I'm doing toolpathing inside of Fusion, I want fast calculations initially, and then I could go back and adjust my tolerance to get a much more precise toolpath. Now, in most cases, let's say for a mold cavity, I've probably done the same toolpath, made a ton of edits 30 to 40 times. We've all done it. Now, if I have to wait 3-4 minutes every time I do that, which is rare, that's going to add up over the day, right? You're looking at wasting a couple of hours just on calculation time. Now, if I made my tolerance much dramatically higher, my calculation time is dramatically reduced. So again, I could do those, 8 or 9 passes that I need, get it where I like it, then come back and throw tolerancing at a much lower amount, as well as my smoothing, to go ahead and wrap that up. So as you can see, the tolerance and smoothing is super important in Fusion, especially when you're doing anything that's a 3D toolpath. I hope this really helps you guys all out. As always, I'm Fusion Phil with JIT CAD CAM. It's not what you know, it's who you know, and you guys know us over here at JIT CAD CAM. If you have any questions about this content or need any help with your Fusion 360, feel free to put in a ticket with the link down below. And as always, have a great rest of your day.